What's up guys, and welcome back to the Secret Letters of a Hacker. Now in the first half of this video I'm going to discuss what is static and dynamic analysis, and in the second half of this video I'm going to analyze some ransomware for you guys, so make sure you stay tuned for that. Now let's go ahead and jump into our scenario, which is that one of your users was sent a file from a strange email address and it needs to be vetted before it's allowed on the network. And since you're the security admin, it was sent to you for analysis. So again, there's two ways to go about doing this. The first way is through static analysis, and what that means is that it's a way of looking at malware to identify its behaviors without having to run the code. Even though running the malware would be the most accurate way to determine its behaviors, it also means that you're going to have to infect your system, and it may be difficult to fully control the behavior of an unknown piece of malware. Now, malware is generally one of two types. It's either going to be obfuscated or it's not going to be obfuscated. And all that means is that the malware author will jumble up the code, rendering it unreadable during static analysis. And a common way of doing that is using rot13, and all that's doing is rotating the code 13 times to what was once readable to now what is unreadable. Now, malware is also either going to be packed or unpacked, and the reason for packing malware is that it will try to evade any antivirus signatures. Since the decompression stub isn't malicious in nature, it won't usually get detected. Also, the malware author can easily change the compression or decompression algorithm without having to change the malware code underneath it, and this will result in a completely different executable hash that will try to fly under the radar from antivirus signatures. And the second reason for packing malware is to shrink the executable, which makes it less noticeable when it gets downloaded. And here's an example of packed malware. This was packed using UPX, which is a common packer, and this was analyzed through CFF Explorer, which we'll cover during our static analysis. Now, the second way to analyze malware is through dynamic analysis, and this is through code execution to identify its functionality, understand its technical indicators that are used in antivirus signatures. Now, these indicators can reveal things such as domain names, IP addresses, it'll reveal the file path locations, it'll reveal any type of registry modifications and things along those lines. Dynamic analysis can also reveal any type of communications with a C2 server in an attempt to download additional malware files. And some typical tools for dynamic analysis will include Wireshark, Process Monitor, and Process Hacker. Now, to help us with our analysis, we're going to utilize a distribution called Flare VM. And what this is a Windows-based security distribution for malware analysis, incident response, and pen testing. So if you don't have a copy of Flare VM, I'll go ahead and drop it in the comment section below. And some of your applications that come inside Flare VM will include your debuggers, your portable executable analysis tools such as PE Studio and PEID. It'll have Metasploit in there. You'll have your text editors, and you'll have a ton of different utilities. So now that we have all the definitions out of the way, let's go ahead and analyze some ransomware. Alright guys, so here we are on our Flare VM machine. So let's go ahead and open up our malware, and we're going to take a look at some ransomware. By the name of it, we can't tell anything about what it is. So let's go ahead and open up our first analysis tool, which will be File Insight. And what we're going to do is just drag it into here. So right off the bat, we can tell by the first two hexadecimal bits that this is a portable executable, and that's classified by MZ. So what that means is that this file is actually a executable file designed for a Windows machine. And we can double check that by going into Utilities, and we're going to go into Exe Info, and we'll go ahead and drag our ransomware into here. And in here we can see that this is not a packed ransomware. If it was packed, it would tell us what it would be packed with right over here. And we can see that its subsystem is a Windows GUI. So let's take a look at its header info, and it actually gives us its file icon. So if we go ahead and change this to, let's say, flappybird.exe, we should see it change to its icon. And there you go. So this file was actually an executable designed for Windows machines, and let's see if we can get any more info out of it. So let's go back into our file insight and let's see if we can pull out any strings. So again, if this was obfuscated, this would all be jumbled up and unreadable. Since we can read it, we can determine that it's not obfuscated and it's not packed. So right off from the rip, we can see that there's an email address, official mail ownerhacker@hotmail.com, and it looks like this might be a Bitcoin address. We can copy that and double check that in a second. You can see Bitcoin accepted here. Localbitcoins.com is a web address. Ransomuserlocker.exe, this is probably what it was called previously. And there's references to Bitcoin, Microsoft, references to Ransom Locker, legal trademark. I wonder if it's trying to hide as a Microsoft product. We'll take a look at that in a second. Looks like it pops up a text box too. Usually when you do run ransomware, a text box will pop up. Another reference to cryptocurrency. So let's go back up here and see what this, if this is their Bitcoin address. So let's copy that. And let's see if this is a Bitcoin address. And it is a Bitcoin address, and they've received 4,000 Bitcoins. Look at all these people that submitted Bitcoins to this ransomware. That's a lot of Bitcoins. How much is 4,000 Bitcoins? Let's take a look and see how much this ransomware made off of people. BTC to USD. So this ransomware file generated $29 million off of people. Wow. That's crazy. That's a lot of transactions. So let's continue with our analysis. Let me go ahead and change this back to something else so I don't accidentally execute it while I'm doing static analysis. Now, a good practice is to analyze your malware in a different operating system than it's designed to run on. Since we know this is designed to run on Windows, it would be preferable to analyze this in a Linux machine. So let's go ahead and open up another tool. Now, a tool that I like to use and a lot of people like to use is PE Studio. So we can close that, close that. Let's go ahead and drag our ransomware into here. And PE Studio is great because it gives you a ton of information through its interface. It'll give you the indicators, it'll reach out to virus total. As you can see, 48 detections out of 66. It'll give us our DOS header, file header, optional headers, directories, libraries, imports, strings, debugger, and a ton of good information in here. So let's go ahead and take a look at these indicators. Now, level 1 is your most severe level, and as you can see, there are a lot of high level indicators. The file reference strings tagged as blacklist, there's 11 of them. The file reference is Microsoft.com. We saw that in our original analysis. URL, some more URLs that are blacklisted. So this file has administrator privileges. Let's go ahead and take a look at virus total, and pretty much all your mainstream antivirus solutions detect this. So let's jump into the file header and see how old this ransomware is. So here's our compiler stamp. Now, malware authors can throw off the compiler stamp. So it looks like though that this was compiled January 15th in 2018, which was about a year ago, and it's now detected across the board, which is good. Here is our optional header. As you can see, our subsystem is a GUI, which would make sense because it's a Windows executable. Our libraries, it looks like it calls Microsoft.net, and our imports, it's importing core X main. We can take a look at the strings, and over here we'll see again the strings that are not obfuscated. Let's see, C users. Again, we see ransom user locker.exe. That's probably what it was originally called. Create encryptor. So it looks like these right here will be your cryptography, where it's encrypting everything. Again, we see some more cryptography. Get machine name, get username. It looks like it's grabbing information as well. We can organize this by any of these headers up here. So let's organize by what is actually blacklisted, and you can see the cryptography is blacklisted, and it looks like that again it's trying to fly as a Microsoft product by using Microsoft.com copyright 2017, but it's actually, its internal name is ransom user locker.exe. So a ton of good information using PE Studio. Let's go ahead and analyze this with another utility, and let's jump into Puppy. We'll go in here and we'll throw our ransomware into Puppy. Again, we have the file header, and it also says that this was compiled back in January 2018. And our DOS header, which is hexadecimal 5A4D, which means that it's a portable executable. So that means again that we're looking at a Windows-based exe. Again, you can see that here, portable executable. Again, we have our entry point, which is here, and it's calling core X main. And here you can see that they tried to change the date stamp to January 1st, 1970. So here are some more strings that we can look at, and you can see it makes reference to Bitcoin, another reference to ransom user locker, reference to Microsoft.com. Again, here is their email address to contact them. Here's their Bitcoin address, and it looks like this is Korean Bitcoin. I wonder if this was written in Korea. The fact that they spelled official mail wrong kind of tells me that English is not their primary language, so they could be in Korea. Bunch of garbage text. So it looks like this ransomware will also disable Task Manager, which makes sense because if you're the malware author, you don't want to be able to have the user just open up Task Manager and kill your application. So it makes sense you would want to disable Task Manager. And it looks like it changes, it does something with the wallpaper. Maybe it throws up another box or something like that for the wallpaper. Let you know you're infected. Here's a README text file. Let's see what the URLs are. Reference Microsoft, reference some cryptocurrency. Not sure what Inkscape is. So I think we have a good amount of information to know exactly what this file does. So thanks for watching, and I'll see you in the dynamic analysis.